In this question, we're asked to determine a relationship between the pressure drop down a pipe, delta P, with the pipe length, fluid velocity, dynamic viscosity and pipe diameter. And we're also given a little bit of extra information that it's observed that the pressure drop varies directly with the length. So how do we solve this? Well, again, we need to find this relationship, so we use Buchan and Pi theorem. And just to remind you, the first step is to identify all the dependent and independent variables. So our dependent variable is the change in pressure, and we're saying that as a function of the pipe length, the fluid velocity, viscosity and the pipe diameter. The second thing we have to do is to count the number of variables, and then in this example we have 5, the pressure, length, velocity, viscosity and diameter. We then need to write each variable in terms of its fundamental units. So obviously pressure is pascals or newtons force over area, or mass times acceleration over area. So that gives you mass over length over time. Length is obviously equal to length, velocity is length over time. Viscosity we've derived before, again, is mass over length over time, and diameter is also a length scale. We need to count the number of fundamental dimensions, so these all have a combination of ml or t, and so therefore j is equal to 3. Now this is also the one of the trickier parts is selecting the repeating groups, and tricky in the sense that there is no real hard and fast rules other than that each of you need to choose 3. J, but j is 3, and they must all have your fundamental units in. So we've gone for velocity because it's got time in, viscosity because it's got mass in. We can't choose P because that's our dependent variable, so we could have chosen between L or D, and you see that I've chosen D. Now the reason for that is you actually come to see the end of the analysis. This is the right choice, but we were given that extra piece of information at the start that the pressure kind of varies with the length. So that kind of implies that these two are, that because of that relationship, we shouldn't have L in our repeating set. Okay, we want to have the diameter in our repeating set. So these are the 3 that we've chosen. And we have 5 variables, 3 fundamental units, so we need to find 2 groups. So our first dimensionless pi group is the one with our dependent variable in, which is change in pressure. So that's a function of our repeating set, which is velocity, viscosity and diameter. We don't know what that relationship is, so we raise each to the power of a, b and c. We substitute in the fundamental dimensions, so this is for pressure, velocity, viscosity and diameter. Then we write an equation based on the exponents of each of the fundamental units. So for mass, this is dimensionless, so there is no units of mass on the left hand side. We got mass in the first term, not in the second term. Not in the second term. Mass in the third term, so it's m to the power of b, and not in the final term. For doing the same thing for length, again this side's dimensionless, so it's 0. We have length to the minus 1 in our first term, length to the power of a in our second term, to minus b in our third term, and to c in our final term. In terms of time, we have it dimensionless on the left hand side, to minus 2 in our first term, minus a in our second term, minus b in our third term, and time doesn't appear in our final term. So now we have 3 equations, 3 unknowns, a, b and c, and we can solve. And if you do that, you find out that a and b are equal to minus 1 and c is equal to 1. So substituting that back in to our relationship here and writing in this form, we can see that for our first dimensionless group, the change in pressure times the diameter over viscosity times velocity, and this is our first dimensionless group. But we said that we needed to calculate 2, so using the other variable, length, and the repeating set, so this bit stays the same, we can do exactly the same process to find the relationship for this dimensionless group. So say that the rest of this stays the same, but we're just changing this one. So we've got L here, and that has units of L. And if we go through it, we actually see here in terms of mass, there is only mass in the third term. Okay, so you can see here, immediately see here that b is equal to 0. In terms of length, we've got length in the first term, second term, third and fourth term. And also in terms of time, time doesn't appear in our in this length here. So it's equal to 0, and then we've got minus a, minus b, and it doesn't appear in the last term. So we have three equations, three unknowns we can solve, and we actually see that a and b are equal to 0, okay, and c is equal to minus 1. And if we substitute these into our things, we actually see that our second pi group is length to diameter ratio. Okay, so also you can see straight away that this is dimensionless. So the final step is to relate our dimensionless group with a dependent variable with the dimensionless group to the independent variables. So this is our first dimensionless group that we got that had a dependent variable in, and it's a function of our dimensionless group of independent variables, which is L over D. So writing this out, we times in by a constant, so some function, and we can also multiply up from the left hand side. We end up with this relationship. So we can see here that the change in pressure is equal to some constant times the length, viscosity, velocity, all over the diameter squared. So I just want to go back and just make comment on the repeating set. So if you'd done this analysis and you'd actually chosen L as the repeating set instead of D, then you would have ended up with a different relationship. You'd have actually ended up with L on the bottom, and you can see now that that wouldn't have made sense, because if you think about it, if you have a pipe and you change the length, you'd expect the change in pressure of quadsat length to increase, not decrease. So therefore the length should be on the top, not on the bottom. And the same with diameter. You'd expect as you increase the diameter of the pipe, the pressure drop down the length of that pipe to drop. So this makes sense. So that's what I was saying earlier, in that choosing your repeating set and your variables, you need to have some knowledge of the system. You can't do it independently of that. You've got to apply some knowledge of that system.